Hello and welcome to lesson 10-2. Today we're going to look at quadratics in standard form, and this is the part 1 video. If you recall from lesson 10-1, we saw that the a value of this equation, y equals ax squared plus bx plus c, we saw that this value up here will tell us the direction of the parabola, so whether it's u-shaped or like that upside down u, and we know that it's going to affect the width of the parabola. So essentially the smaller a is, the wider the parabola, okay? In lesson 2, what we're going to do is we're going to look at how b is going to affect our parabolas. So to begin with, we're going to look at the property that says that the graph of y equals ax squared plus bx plus c has the line x equals the opposite of b over 2a as its axis of symmetry. Now, yesterday we kind of talked about that briefly. If you have a parabola that looks something like this, your axis of symmetry is that line that goes right down the center that splits that parabola in half, okay? This equation here also will find the x-coordinate of the vertex of your parabola. So that would be an x-coordinate, and we'll have to find the y-coordinate if you need to find the coordinate point itself. So when we look at these three graphs here, I have y equals 2x squared plus 2x, y equals 2x squared plus 4x, and y equals 2x squared plus 6x. So they all have the same a value. They all have the same x-intercept of 0, 0, and they're all facing upwards, or essentially they're a U shape, okay? Now, the only difference, however, is their axis of symmetry. And usually axis of symmetries are shown with a dashed line, okay? Because it's not really a point on your graph. It's just there to show you that this is kind of where your midpoint would be, okay? And if we want to go and calculate this, if I know that the axis of symmetry is found by x equals the opposite of b over 2 times a, here my b value is 2, so I take the opposite of that, which makes that a negative 2. Then I have 2 times my a value. Well, a is 2 here, so I really end up with a negative 2 over 4, or a negative 1/2. So that, as you can see right here, is a vertical line through x equals a negative 1/2. And you can do the same thing for the second and the third graphs as well. So looking at example 1, we have to graph the function of y equals a negative 3x squared plus 6x plus 5. Now, we've done tables before to graph these, and those are like a good rough start. But what we're going to do is we're going to start looking at ways that we can make our graphs better. One of those ways is going to be to plot the vertex. The vertex is a very important point on your graph. Okay, it tells you either the highest or the lowest point. So we need to know where that point is located. So to calculate the vertex, I'm going to find that x-coordinate by using x equals the opposite of b over 2a. So when I plug that in, I notice that my b value is 6. So I have the opposite of 6 divided by 2 times my a value is a negative 3. So when I simplify this, I end up with a negative 6 over negative 6, or a positive 1. So I know that my vertex has an x-coordinate of 1. Now I have to find my y-coordinate. Well, I'm going to find the y-coordinate by plugging that 1 into this equation. So I really end up with a negative 3 times 1 squared, which is 1, plus 6 times 1 plus 5. Well, negative 3 plus 6 is going to give me 3 plus 5 is 8. So my vertex is at the point 1, 8. So I'm going to go ahead and plot that point. So at 1, 8, I have my vertex. I also know that my axis of symmetry goes through x equals 1. So I'm going to go ahead and draw that in. And I'm just going to draw that in as a dashed line so that I know that this is where my graph is going to be split in half. And then I'm going to create my table. So I have my XY table. And me personally, I always like to put my vertex in the middle. So I know I have 1, 8 in the middle. And this is Y here, sorry. So I'm going to pick a point on either side of that vertex. So I'm going to pick the point 0 and 2 just because they're easy numbers. And when I plug a 0 in, I see that I get 5. If I plug a 2 in, I have -3 times 2 squared is going to give me a -12. Then I'm going to go 6 times 2 is a +12. And then I'm going to add 5 to that. So that's going to give me the coordinate point 2, 5. Now I'm going to go ahead and plot the rest of these points. And I'm just going to go ahead and connect them. And I'm going to get something that looks like this, okay, as a rough sketch. So it's still a rough sketch, but I'm a little bit more concrete in the fact that I know what my vertex is and I know where my exact axis of symmetry is. So we're getting closer to having a better parabola. So for example 2, it says, in a professional fireworks display, aerial fireworks carry stars upwards, ignites them, and then projects them into the air. Suppose a particular star is projected from an aerial firework starting at a height of 520 feet, an initial velocity of 72 feet per second. We want to find out how long it's going to take for the star to reach its maximum height. And then once we know that, we want to know how far above the ground it will be. Well, back in 10.1, we looked at an equation that says h equals -16t squared plus c. Okay, this was for a projectile that was literally just kind of like dropped or something that was falling because there's no force or no velocity behind it. What we're going to look at today is I'm going to look at an equation that is very similar. So it's -16t squared plus vt plus c. Okay, both equations, the h is our height, okay, at any given time. T is still going to be our time in seconds, and c is still our initial height that we're starting out at. The only thing that's different is this v. This v is what we call the initial velocity. Okay, so that's like the velocity with which the object was thrown with. So if we go back and look at our equation here, we can see that the starting height was 520, that initial velocity was 72, and now we have enough information where we can plug this all in. So really, I have h equals a -16t squared plus my velocity of 72 times t plus my initial height, which is 520 feet. So now what I need to do is I need to find how long or the time that it will take for that star to reach its maximum height. Well, I know that the maximum height, or I know, I guess, the shape of this graph is going to be a parabola, and it's going to be something that's shaped like this. And I know that because I start out with that -16t squared. So I'm really looking to see how long it's going to take to get to that point and then what that height is going to be. So this is all dealing with my vertex. So what I'm going to have to do is I really need to find the coordinate of that vertex. So what I'm going to do is I'm going to look for the x coordinate, which in this case is really, I'm going to call it our t value. So our t value then is going to be the opposite of b. Well, b is really 72, and I'm going to divide that by 2 times a, which is a -16. So I end up with a -72 divided by a -32, and 72 divided by 32 is actually going to give me 2.25. So because this is my x coordinate, this is really 2.25 seconds to reach that height. Now, I want to find out what that maximum height is. So to find my height, what I'm going to do is I'm going to take that time that I just solved and I'm going to plug it into my original equation. So my height is equal to a -16 times this time that I just found of 2.25 seconds. I'm going to square that. I'm going to add that to 72 times 2.25 and add that to 520. And when you simplify all of this, you should get 601. Well, our height is always measured in feet, so that tells me that after 2.25 seconds, we're going to reach the maximum height of 601 feet. We'll do 2 more examples to kind of help make this make sense. But please let me know if you have any questions on this type of a problem. For example 3, it says a ball is thrown into the air with an initial upward velocity of 48 feet per second. We want to know how many seconds is it going to take for the ball to reach its max height. And then once we know that, we want to find out what the maximum height is. So to begin with, I'm going to write my equation. So my height is equal to a negative 16t squared. My velocity we said was 48, so that's plus 48t. And my initial height is actually going to be 4. It looks like I cut off part of the problem, and I do apologize for that. So this ball is being thrown from a height of 4 feet. So my equation is h equals negative 16t squared plus 48t plus 4. So what I'm going to do is I'm going to go ahead and solve for part A. It wants to know how much time it's going to take to get to that maximum height. Well, time is going to be found by taking the x-coordinate of that vertex, which is the opposite of B, divided by 2 times A, or 2 times a negative 16. If I simplify this, I get a negative 48 divided by a negative 32. And if I simplify this all the way down, I'm going to end up with an answer of 1.5. And again, because my time is measured in seconds, I know it will take 1.5 seconds to reach the maximum height. So now for part B, I want to find out what the maximum height is. So now I'm going to plug in my time into my equation. So I have 1.5 squared plus 48 times 1.5 plus that 4. And I said if I square my 1.5, multiply by negative 16, and add it to 48 times 1.5 plus 4, I'm going to end up with something around 40 feet. And that would be my maximum height. And now for our final example, it says the total profit made by an engineering firm is given by the function P equals x squared minus 25x plus 5,000. We want to find the minimum profit made by the company. Well, even though we're talking about profit here, I can come up with a couple of things. Okay, so because this is a quadratic equation that has a positive a value, I know I'm dealing with a graph that is U-shaped. So if I want to find the minimum profit, I'm really looking for that vertex point. So my P is really my Y value, so I'm going to have to solve for X first. And I can solve for X by doing the opposite of B, which in this case is a negative 25. So the opposite of a negative 25 is really a positive 25 divided by 2 times A. Well, A is a positive 1, so I really end up with 12.5. Now, in order to find my profit, all I have to do is I have to plug in that 12.5 into my equation, and then I just have to solve. So if you notice, you can kind of come up with the same deduction. It looks like they were starting out with around $5,000. Okay, this 12.5 could be something like years or months or something like that. So once I plug that 12.5 in, I can see that my profit is going to equal $4,843.75 for that minimum amount. Please let me know if you have any questions. Otherwise, I will see you guys in class, and I hope you guys have a great day.